Hello class and welcome to another physics video lesson. We're going to start with a new topic today. This is topic 1.3 and 1.4, and this topic we're going to look at mass, weight and density. In this video lesson in particular, we're going to look at topic 1.3, mass and weights. We're going to look at what is mass, what is weight, how to calculate weight, and how do we measure mass and weight in physics. So what is mass? Mass is the amount of substance in the object. If the object has a lot of substance, let's say you have a big rock, then it has a lot of mass. If the object is small and doesn't have a lot of substance in it, then it has a small mass. It's not very heavy. So mass is a value that is always constant no matter where you go. Let's say I weigh around 70 kilograms. When I'm on Earth, I'm 70 kilograms. When I go to the moon, I'm still 70 kilograms. So my mass doesn't change. And mass has a lot of unit. There's grams, there's kilograms, there's tons, there's pounds. But the SI unit for mass is the kilogram. Weight, on the other hand, is different than mass. So make sure you remember, in physics or in science, mass and weight are different. So mass is the heaviness of an object, and mass is the quantity that's in kilogram, while weight, on the other hand, describes the force of gravity acting on the object. So if the gravity pulling on the object is stronger, then the object has a larger weight. If the gravity pulling on the object is lighter, then it has a small weight. So mass and weight are related, but these two are different. I know in everyday language, in English, we use the word weight to describe the heaviness of an object. For example, someone might ask, what is your weight? And then you reply, your weight is 70 kilograms. In everyday English language, yes, we use weight as something that means the heaviness of the object. But in physics, weight is more the force, the gravity that is acting upon the object, whereas mass is the quantity that we use to describe the heaviness of an object. And for weight, the value changes from one place to another. For example, the weight of an object is more on Earth compared to its weight on the moon. And you will see what I mean by this when we do the example later. Now, weight, like I said, is a force. It's not in kilograms. And because weight is a force, and especially it's related to the force of gravity, it has the same SI unit as gravity. Its unit is the Newton. So how do we measure weight? We measure weight using a spring balance or something we call a force meter. So these balance or these meters actually measures force, and we can also use it to measure weight. To measure mass, we either use an electronic balance, or we use a beam balance, or we also can use an equal arm balance. We can calculate the weight of an object using this formula. W stands for weight, M stands for mass, and G stands for something that we call the acceleration due to gravity. Okay, so it's written down there. You can pause this video to copy that down to your notes. Now, something very important to note and very important for you to remember, the acceleration due to gravity on Earth, on this planet here, is 10 meters per second square. So whenever you do calculation and when the question tells you that the object is on Earth, G, just this quantity in this formula, is always 10. So basically, if you want to find the weight of an object on Earth, what you do is you multiply the mass with the number 10, and then you'll get the weight. For example, I have a mass of 70 kilograms. And if I want to know what's my weight on Earth, I just 70 times 10, my weight is 700 newtons. Let's do example 1 and you will see the difference between mass and weight. So the example read, the acceleration due to gravity on Earth is 10 meters per second. So G is 10. And the acceleration due to gravity on the moon is 1.6 meters per second. So on Earth, it's 10 meters per second, while G on the moon, so GM, I'm just going to write M, small m, to indicate that that's the moon's value for G, and that one is 1.6 meter per second square. Okay, so why is Earth 10 and moon is 1.6? So the moon has a weaker gravity. That's why its value for g is smaller. So g is just another value that indicates the gravity of the planet or of the object. So how much does a book of mass 1.5 kilograms weigh on Earth and on the moon? So let's calculate the weight of the book on Earth first. What's the formula for weight? It's this one here. The mass is 1.5. What's g? What's the acceleration due to gravity on Earth? It's always 10. So this number you have to remember. So 1.5 times 10, that gives you 15 newtons. Now let's calculate the weight of this book on the moon. We use the same formula. Mass is 1.5. What is g for the moon? So the moon has a weaker gravity, so its g is also smaller. So the g for moon is 1.6, and you calculate that, and the answer is 2.4 Newton. So you can see in this example here, for the book, it has the same mass regardless whether it's on Earth or on the moon. So the book is 1.5 kilograms on Earth. The book is 1.5 kilograms on the moon. On Earth, the book has a weight of 50 newtons, and on the moon, the book has a weight of 2.4 newtons. So the weight is less on the moon. Okay, so this is what I mean when I say the weight changes depending on where you are. And you can see the weight of the book is less when the book is on the moon. Same thing in your case. If you are on Earth, you have a certain weight, but when you go to the moon, your weight will be smaller. That's why you are able to jump higher on the moon, because you have a smaller weight. There's less force, there's less gravity pulling down on you. So you are able to jump higher on the moon. So that's pretty much it for this video lesson and for this part of the topic. Just make sure you remember that mass and weight are different in physics. Mass is the amount of substance in the object. It stays the same no matter where you go, and mass has the unit of kilogram. So mass is more like the heaviness of the object, whereas weight, on the other hand, depends on the gravity that is acting on the object. So weight is actually a type of force, and weight changes depending on where you go. If you're on the Earth, your weight is a certain way, but if you're on the moon, your weight will be less. And because weight is associated with force and gravity, weight has a unit of newtons, not kilogram. And make sure you remember the formula for weight. W is equal to m's times g. In the next video lesson, we're going to talk more about gravity, gravitational field, and something called inertia.